Alright, so page 266, right at the top. So we started talking about the extreme value theorem yesterday. Does anybody remember what that actually told us, the extreme value theorem? Because that's going to be important today when we get to a few of these problems, what that actually means. The extreme value theorem.
If f of x is continuous on a closed interval AB, then f of x is guaranteed to have at least one absolute min and one absolute max on a closed interval.
So it's important that it's continuous. If it is continuous, you're guaranteed to have at least one absolute max and min. If it's not continuous, like if you have a jump or a hole for some reason in your graph, you're not guaranteed to have that absolute max or absolute min. You could still possibly have one, you're just not guaranteed to have it. Alright, so use the extreme value theorem to locate the absolute extrema of the function listed there on the given closed intervals. Your algebraic results should concur with your graphical conclusions from the previous page. So they give us an interval from -4 to -1, and we're talking about this original one here. So how, thinking back to the previous unit, how would we find out where maxes and mins would be? If we're given an original, and I just tell you, find the max and mins, find the extrema. Yeah, derivative and find critical points. So that's what we're going to do. We're going to take the derivative of that original function at the top. We get -3x squared minus 12x minus 9. We would like to be able to factor it and set it equal to 0. I can pull out a -3. That's x squared minus 4x plus 4x plus 3. Will this factor? Or are we going to have to use the quadratic formula? Yes, it does factor. Okay, so that's nice. Again, this is just from the last unit. We're finding our critical points when the derivative is equal to 0. So we know at x equals -1 and -3 we have critical points. Now this question is specifically asking about absolute extrema. So at the top, they're specifically asking just about the absolute extrema. Where do we have an absolute max? Where do we have an absolute min? So think back to yesterday. We talked about the absolute extrema. Where can those occur? Where can the absolute extrema occur? Endpoints?
F prime of x is undefined.
Undefined? And when the derivative is 0. So if the derivative is 0, that's when you have a min or max. It could possibly be an absolute also. Whenever it's undefined, well, we don't have any spots in this one where it's undefined. And endpoints. So when they give you an interval, these are endpoints. So where we need to test for absolute extrema, so we're going to test endpoints and critical numbers. That's what we're going to test. Endpoints and critical numbers. So we're going to test f of -4 because that's an endpoint. We're going to test f of -3 because that's a critical point. And we're going to test f of -1 because it's a critical point and an endpoint. So those are the 3 points we're going to test. Now again, we're testing those in the original. So we need to get 3 answers here. So take these values and plug them into the original and see what your answers are. You can use your calculator if you want to, but you have the original function at the top, plug it in, and let's see what your values are. Ariana, I know you just came in. Are you okay with what we've done so far? just from the past unit, finding critical points, and then we're testing endpoints and criticals, because at the top, they're asking for absolute extrema. We're looking for the absolute maxes and absolute mins. So again, from yesterday, we know those can occur at endpoints, at critical numbers whenever the derivative is equal to 0, we found those, or when the derivative is undefined, but we didn't have any points where the derivative was undefined. So we're just going to test our endpoints and our critical numbers. Did anybody find any of those values yet? Any one of them? You don't have to have all of them, but did you find any of them? Okay, what'd you get?
6 for negative 4.
Okay, I agree with that. 6. Any other ones? Anybody get yet? Yes, Sola.
2 for negative
Okay, 2. I agree with that.
And 6 again for negative 1.
Okay, very good. And 6 for the negative 1. Okay, so what we're talking about, we found endpoints and critical numbers. We plugged them into the original, so we're talking about a specific interval. Within that interval, is it continuous? Like if we pick any x value between negative 4 and 1, are we going to be able to get an answer in our original? If we would plug in any x value, yes, it's continuous. We would be able to get a number anywhere on that interval. So we know it's continuous, so according to the extreme value theorem, we should be able to find an absolute max and absolute min. While looking at our endpoints and critical numbers, we found that we have 2 absolute maxes because they are the same. And at the critical number negative 3, we found we have an absolute min. So that doesn't say with that entire function that that's the highest and lowest spot. It's saying within that interval, those are the highest and lowest spots. Within that interval. Does that make sense? We're not looking at the entire function, just between negative 4 and negative 1. Alright, so very similar. The next problem. So we're dealing with the same function, but the interval has changed. So if you want to rewrite it, you can, but all of this information here would just transfer to here, taking the derivative and solving for your critical points, because we're using the same function. If you want to rewrite it, you can, but we're going to get the same critical points over here. Negative 3 and negative 1. Again, it's the same function, but the interval has changed, so you need to check endpoints and critical numbers. So we want to check f of negative 4, that's an endpoint. F of negative 3, it's a critical number. F of negative 1 is a critical number. And the new endpoint is f of 1. Now again, some of these we have the answers for already, so you can copy them over. Some of them we will have to find new answers for. So when you get the new one, let me know what you get. Again, this is the interval has changed, so our answers could change. Go ahead, Braden.
Negative 14.
Negative 14. So what do you think we can make about a conclusion on each 4 of these? Each of the 4. What would each of them be? So the first one is a what?
Absolute.
Yes, I agree with that. Absolute max. What about this second one? So it's not the highest, it's not the lowest, so they're just asking for absolute extrema. Yes, it's a relative, but we're not even going to label it because they're asking specifically for the absolutes. So that is neither. This one here, f of negative 1. Absolute max again. And f of 1, negative 14 is your what?
Absolute min.
Yeah, very good. This is some relative extrema, we're just not sure what at this point. Are we okay with that? We had an answer here, but this one is neither, because it's not the highest or the lowest, and they're asking specifically for absolute extrema. Okay with both of those examples? Alright, let's move to the bottom then. So thinking about that extreme value theorem, think about yesterday, Braden repeated it for us at the beginning of class. Remember what that extreme value theorem says and different possible spots for absolute mins and maxes as we look at the following three. So for each of the following functions, state specifically why the EVT is or is not applicable on the given interval. So just look at the first one. They give you a function. The interval is from -5 to 0, so those are the x values you can plug in. Would the EVT apply to this? Why or why not? So think about what the EVT says if you need to look back at the statement. It's from yesterday. Does this apply to this first h of x function? Dan?
No, it is not continuous on the interval -5. Is not on the. It's not continuous on an interval -5 to 0 because it has a vertical asymptote at -3.
Okay, so we're going to say EVT does not apply because h of x is discontinuous at x equals -3. And that's within the -5 to 0 interval. So I just wrote within -5 to 0. It's within that interval. So if we plugged in -3 here, we would get 0 on the bottom, which would cause undefined, which means it's not continuous at that point. So we cannot use EVT. Very good. All right, with the next one, does the EVT apply? Dan?
The EUTV does not apply because on the interval -5, 0, x is not continuous because everything less than 3, well, less than -3. No, less than 3.
Yeah,
Wait.
3.
Yeah, less than 3 is undefined.
Yes, so EVT doesn't apply because g of x is only continuous for x greater than or equal to 3. It's only continuous for x greater than or equal to 3. And that's not within -5 to 0. It's only continuous for x values that are greater than or equal to 3. If you plug in something less than 3, you get a negative, and you have to take the square root of that, so it does not apply. It doesn't work. It would give you imaginary numbers. Are we okay with 1 and 2? All right, on to the third one then. Does the EVT apply? Does the EVT apply? Yes, it does.
Continuous within the interval.
Yes, it is continuous within the interval. What value would make this non-continuous or discontinuous? -7. So we're going to say EVT does apply because f of x is continuous for x values greater than, not greater than or equal to, just for x values greater than -7, and that's within -5 to 0. So it does work. Within that interval, this will be continuous. If this interval started at -7, it would not be continuous because your x values have to be greater than -7. But we're at -5, so it will work. Any questions about any of those three or anything on this first page? Feel comfortable with the ideas? All right, let's go ahead to the next page then. All right. So we have 4 problems on this page. Given the function below, determine the absolute extrema values of the function on the given interval, provided the extreme value theorem is applicable. If it is not, state specifically why it is not applicable. So starting out with the first one, if you think about the EVT, they give you an interval. Will the numbers within that interval be fine with this function?
Yes.
Yes, they're not going to cause any trouble. So the first thing we need to do is, how do we find our critical points? Find the first derivative. So let's go ahead and find the first derivative. (3x squared minus 4x minus 3). And we have to set that equal to 0. Is there any combination that will allow us to factor this? This is positive, not negative, sorry. There we go. Is there any combination that will allow us to factor that? No, we have that negative at the end, and that's going to give us some trouble there with the negative in the middle, and I don't see anything that's going to work, so we have to use quadratic formula. The opposite of b, plus or minus square root b squared is 16 minus 4 times a, which is 3, times c, which is negative 3, over 2a, which is 2 times 3. So I'm just going to simplify to 6 right off the bat. Are we okay with the quadratic formula since we've used that before? Okay. So we need to simplify the quadratic formula and get 2 decimal answers. So go ahead and get 2 decimal answers for us, please. Those will be your critical points. So please find those. Did anybody get any of the decimal values yet? 1.87, we'll go with that. If you rounded to 2. And the other one? Did you get it right? What is it? Negative 0.54, thank you. So those are your critical points. Those 2 decimal values. That was just from simplifying the quadratic formula. So think back to that example we just did on the previous page. If you have critical points and you have an interval, what do you have to check now? We need to check the endpoints and the critical points. Yeah, so f of negative 1, f of this negative 0.54, f of 1.87, and f of 3. So you need to check those in the original function. So go ahead, take those values, plug into the original function, use your calculator, and find the answers for these 4. You should get 4 answers here. Once you find one, let me know. You don't have to have them all to tell me what one of them are.
Negative 0.54 is negative 1.121.
Negative 1.121. Okay, I agree with that.
1.869 is negative 8.065. And the other 2 are negative 2.
I agree with that. And I agree with those. So those are the four values you should get. -2, -1.121, -8.065, and -2. Those are the four values. So what can we make as our conclusion? Our conclusion?
F negative 0.54 is the absolute max. And F 1.87 is the absolute max.
Very good. That's what we can conclude. Our absolute extrema would be those two. Absolute max and absolute min. We don't know for sure that what kind of extrema the endpoints are, but they are not the absolute max or the absolute min. Our critical points end up being our absolutes. Any questions how we arrived at that answer? Alright, so the next one might seem a little trickier because it's involving trig functions, but we're going to work through the same process. So we need to find derivative. If I have sine squared x, what is the derivative of that? Derivative of sine squared of x. Anybody have it? I think I heard a good idea over this way.
Chain rule shows the 2 sine of x times cosine.
2 sine of x times cosine of x. Very good. And then the derivative of cosine x is just negative sine x. So that's our derivative. And we want our derivative equal to 0. So I can factor out a sine x. And we're left with 2 cosine x minus 1. So that's what we're left with so far. We took the derivative, set it equal to 0. So what we're really saying, when sine x is equal to 0, and when 2 cosine x minus 1 is equal to 0, both of those need solved. So if you think about sine x, think about your unit circle. When is sine of x equal to 0? Think about your unit circle. Zero is another thing for 2 pi, so that's 1. And what else on the unit circle would sine be 0? Pi. So this is just for the sine x part. Are both of these within our interval? Our interval is from pi over 2 to 2 pi. Are both of those within the interval? Yes, so those are good. Because the pi is all the way on the left side. If you think about your unit circle, 0's over here, pi, 2 pi is with 0. Pi over 2 is at the top. So yes, from pi over 2 to 2 pi, pi and 2 pi are within those intervals. Very good. Now we need to solve this one over here. So we actually, if you add the 1 and divide it by 2 to get cosine by itself, cosine of x equal to 1/2. So we want to know what are the x values to get cosine. So cosine of what is equal to 1/2? Cosine of what is equal to 1/2?
Pi over 4.
Close.
Pi over 3.
Yeah, it's pi over 3. So we have pi over 3. What else would make cosine equal to positive 1/2? I think you have the right idea.
It's right below 8 pi over 3. No. 11 pi. No. 7.
So you leave your 3 on the bottom. You're getting close.
5 pi over 3.
Yes, that's it. I knew you would get there. 5 pi over 3. Very good. Are both of these within the interval?
Yeah.
Yes.
Are they?
Pi over 3.
Pi over 3 is not. No, scratch that one out. We can't use that one. It's not in the interval. If you want to make a note and write that, not in interval. So we're not saying that it's not a critical point. We're just saying it's not a critical point within our interval because we have a specific spot we're looking at. So we don't need to worry about that value where we're looking. All right, so we have 3 critical values within our interval that we need to check, and we need to check the endpoints. So g of pi over 2 we need to check, g of pi, g of 5 pi over 3, and g of 2 pi. Again, these need plugged into the original g function, and we can get our values. So go ahead, plug those into the original g, find your 4 values so we can make our conclusion. Again, these values here are just either the critical points or the endpoints. Did anybody find any of the 4?
I over 2 is 1.
Yes, that is 1. I agree. Anybody else have any of them?
I is -1.
Very good.
5 pi over 3 is 1.25.
As a fraction, you can leave it as that. Do you have a fraction? Could you change that to a fraction? If you hit math,
5 over 4.
yeah, 5 over 4
And 2 pi
is
is 1.
1. If you wanted to leave it as a decimal, you could. You're not incorrect. But the fraction answer is a little neater to write here in this case. All right, we have our 4 answers. So what can our conclusion be from these 4?
Absolute min at 5. And the absolute max is the 1 value.
Yep,
So I have
very good. Absolute min, absolute max. Very good. All right, the third one. Third one, same idea. We're going to get a little different result. Do we want to work through that together, or do you want to give it a try on your own first? What do you guys think? Why don't you give it a try? You need to find a derivative first, so make sure you're using the correct derivative rules. Find your derivative, set it equal to 0. See if you can find a critical point. See if you can find your critical points.
So isn't that still considered a critical point? Something's happening there?
Because at that point, the derivative is actually what?
Took the derivative, set it equal to 0, but at that point, you plug in and the derivative is 1. Not defined, so something's happening there.
If you want to check your derivative up here, I have the derivative. I have it set equal to 0. Do I have critical points? I have a critical point on the bottom because if the bottom is equal to 0, it becomes undefined. So my critical point is what? Yeah, x equals -2 is my critical point. Nothing on the top will make it equal to 0 because I just have a constant up there. So I have my critical point. So I need to check endpoints. And I need to check critical points. Oop. There we go. Anybody find any of those values yet?
Negative 3 is 1,
Okay,
and negative 2 is 0, and the last one's 4.
very good. So our conclusion, we know 0 is the smallest, absolute min. 4 is the biggest, absolute max. So if you plug those into the original, these are the results you get. So far we've done well. We've taken the derivative, we've found critical points, we've tested the endpoints and the critical points, and we've been able to find our absolute min and absolute max. So we have one left. Let's take a look at the last one. So we have this function here, and we have an interval. Does this interval work for the EVT? So think about your EVT. What conclusion can we make? Can we go on with the process of taking the derivative? Because this one's not just straightforward like a polynomial that you know you can plug values into. So you kind of have to think about this one before you start. What conclusion can we make? Can we go on with the process? Can we not go on with the process? If we can, let's do it. If not, why not?
Not continuous.
Why? Or where?
I don't know if it's graph is from -1 to 2. Like the graph starts like
Do you have a specific value where you think it's not continuous?
Negative 2.
Yeah, how'd you get that, Ryan?
Because it equals 0.
Yeah, if you plug in -2 squared is 4, 4 minus 4 is 0, and you can't take the natural log of a 0. If you take your calculator and put in natural log of 0, you get an error. So, the EVT does not apply because at x equal to -2, which is in the interval -1, 2, 3, h of x is undefined, and therefore it's not what? This is the important part about the EVT. It's not what? I think I heard it back here. Continuous. It's not continuous. Very good. Because at that one point, if we plug in that -2 and square it, we have -4, that gives us 0. We cannot have the natural log of 0. It's undefined at that point. So the EVT does not apply. We can't say for certain that we have an absolute max and an absolute min. Do we understand how we got that result compared to the other three? Alright, so we have some time. If you have any questions on homework or anything, I can answer those. You have some free time to work on homework, so take the rest of the time to get a jump start on that.